Ancient Indian philosophers categorized the physical world into 5 distinct elements: earth, fire, sky, water, and air, a system known as the Panchatattva. Today, science gives us a much simpler answer. Everything is made of just one thing: matter. In the simplest terms, matter is absolutely anything in the universe that takes up physical space and has mass. But this definition creates a weird tension in our everyday experience. You can easily slice your hand through a pool of water, but if you try to karate chop a solid wooden table, you will break your hand. Both are matter, so why the drastically different rules? Looking at large everyday objects won't answer that question. To understand why a table hurts and water yields, we have to zoom way past what the human eye can see, down to the microscopic building blocks. Down there, the solid, distinct reality we think we know disappears, revealing a single, invisible architecture shared by absolutely everything. The first thing to understand is that matter is not a single, continuous block. It is built from trillions of distinct, individual particles, operating much like a beach made of countless tiny grains of sand. These particles follow a strict set of rules. Rule number 1. There is distinct empty space between them. This diagram of water explains why adding sugar doesn't raise the water level. Notice the empty gaps between the blue water particles. The added sugar particles break apart and slip directly into those pre-existing pockets, leaving the liquid's total volume unchanged. This basic kitchen observation proves a rather staggering reality. Liquids that look perfectly dense and unbroken are actually highly porous, filled with microscopic voids. Rule number 2. Particles are never still. They carry kinetic energy, meaning they exist in a state of constant, chaotic motion. This animation demonstrates what happens when we add heat. The kinetic energy spikes, causing the particles to vibrate faster and aggressively crash into one another. They violently intermix in a process called diffusion. This is the exact mechanism that lets you smell hot, freshly cooked food from across a room. The heat accelerates the food's particles, diffusing them rapidly through the air. Once that food goes cold and kinetic energy drops, you have to lean in close to catch the scent. The third rule governs how things hold together. Particles constantly exert an invisible force of attraction on one another, attempting to lock into place. The intensity of this attraction varies wildly, causing objects to behave very differently under stress. A piece of chalk easily snaps, a rubber band stretches, and an iron nail holds firm. Structural integrity has nothing to do with magic or solid continuous blocks. The physical strength of an object is dictated solely by how tightly its microscopic particles are clutching onto one another. When you balance these 3 rules, the amount of space, the speed of motion, and the strength of attraction, you generate the 3 macroscopic states of matter we interact with daily: solids, liquids, and gases. In a solid, extreme attraction locks particles tightly into a rigid lattice. Weaken that attraction, and we get a liquid, with particles sliding and flowing dynamically. Eliminate it entirely to create a gas, where particles zoom wildly, continuously crashing to generate internal pressure. A block of ice, a glass of water, and a cloud of steam are not different substances. They are merely the exact same particles arranged differently in space. Because these states are strictly defined by kinetic energy and spatial arrangement, they aren't permanent. They can be hacked. If you introduce a massive amount of heat, solid particles gain enough kinetic energy to overpower their attractive bonds. They melt into a flowing liquid and eventually boil away into a gas. But heat isn't the only tool at our disposal. Applying extreme physical pressure can literally squeeze particles closer together, forcing radical, immediate phase changes. Look at how solid carbon dioxide, known as dry ice, behaves at room temperature. It completely bypasses the liquid phase in a process called sublimation, instantly releasing thick, rolling vapor directly from its solid surface into the air. Nothing in our physical world is truly permanent. Everything in the universe, from the stars above down to the cells in your own body, is just a temporary, moving arrangement of tiny particles, dancing to the tune of heat and pressure.